It's camshaft time. This is the original camshaft reground, which was slightly more expensive than buying a new one. But we're in the business of fixing stuff, not throwing stuff in the bin. Now, as I said, this has been reground. There was just a little corrosion on it. And some people get a little bit confused about that, because if you grind this, doesn't that mean your valves open less? Well, no, because they take the same amount off the back. So the difference, or lift, stays the same. And there's nothing complicated going on here. We just need to stick this back in. Basically just like inseminating a cow, except with a camshaft instead of your arm and a cow. Now, on the cam bearings. We did not end up changing the cam bearings. The original ones are fine. The machine shop was going to do that for me. I gave them new bearings and they had the all clear to go ahead and spend money replacing them. But there wasn't even a discussion. They said, you don't need to, waste of time, the original ones are good. Which is typical. These 4-cylinder Land Rover engines are very gentle on their camshafts. Land Rover compensated by making the V8s eat camshafts like they were made of Play-Doh. But in this engine at least, you're normally going to be reusing your original camshaft and bearings. Now on the cam lobes, I'm going to use this Liqui Moly assembly paste. This stuff is for hard metal on metal contact, not for bearings and stuff like that. I'm not sure it will do any harm, but it's specifically designed for things like camshafts. And in we go. Now, obviously, you need to be careful not to drag the cam lobes or the gear in the center across the bearings. Easy. Easy. Oh. This motor is pretty easy because there are access holes on the side. We're in. Okay, so now we need all of this stuff. Here's this big gear, and I think the little bits are in here. Yeah. Right there. Right there. And this plate goes on here. I think it can go either way, but I can see witness marks from the old washers, so we'll put it on the same way. And this is like a giant thrust washer, so we'll add some gloop. New locking tabs. I'll just leave those until I'm sure we don't need to take anything off again. So this just goes here, and yeah, okay. We'll tighten these up now. Just put a screwdriver in the back to get the short side started. Just makes it easier, a little easier to get a chisel in. Okay, that's good. Make sure I get this nasty little burr. It's the problem with using a chisel. Even though that chisel is blunter than a fat man's butt cheek, we still don't want it to leave any burrs. And now we put our timing gear on, and you might not be able to see, but there's a P stamped in here. Not here, there's another P here. That goes on this keyway. This just slides on. Good. So yeah, here, you can see it here. This P, it's fairly faint, but that's the slot that the woodruff key is in. Now this thick washer and a locking tab, and you can see that this locking tab goes through the hole in the washer and into one of these splines. Now we'll just tighten this screw, which should pull the camshaft in. Relax, this is on gentle mode. Wrong size. Okay. I think that's pulled up tight. Now, shall we check our end play? Okay, let's see. What was that? 4? Yeah, 4. It's not going back to 0 though. So let's say about 3.5. What is the number in the book? 2.5 to 5.5. And we're at 3.5. Perfect. And the best way to check this is with an indicator. Basically, what you're measuring is the difference between the depth of the shoulder and the thickness of the thrust plate, plus any wear in the back of the gear. If you don't have an indicator, you could probably measure that with feeler gauges and a straight edge if you really had to, but I don't think it's typical to see heavy wear here, so if everything looks okay, you can probably just, yep. And I'll finish tightening this nut and bend the tabs over once we have the chain on. Just some CRC or some oil or whatever, help everything slide into place. You can see there's a thick side and a thin side. It goes on the thick side first, like so. And it must be right because if we run a straight edge across the edge of the large sprocket, it lines up with the little sprocket down below. And that's all there is to that. This is held in place by the front pulley, which we put on later. And now we'll fit the chain guide or damper. This is the new one, they're inexpensive. Here's the old one. You can see it has a little bit of wear on it, but this is probably done, 300,000 Ks, whatever's on this motor. And it looks brand new compared to any BMW chain guide. It's certainly not going to wear through anytime soon, but we're putting a new one on anyway. And yeah, I'm reusing the old lock tabs. I forgot to order new ones. They'll be fine. In fact, 1/2 of each of these has never been bent over anyway. Okay, let's put the chain on and see how it fits. The engine isn't in time or anything like that yet. I just want to see how the chain sits against this. So what we're looking for in here is a up to 10 thou gap. It's hard or impossible to get a precise parallel gap because there's no real adjustment, just a bit of slop in the fixings. I got it so that the chain was just skimming the pad at the top and a small gap at the bottom. That's the best I could do, and that matches the wear on the old pad as well. When you do these lock tabs, well, first of all what you want is the piece that's bent down around the part. You position that so that it can't turn anti-clockwise. Ideally. You see, if this tab was up here, it could turn all the way around this circle before it stops. Okay, it's half bent. Okie dokie, all done. And I didn't show this, but I always run over the area with a magnet afterwards to pick up any tiny bits of shrapnel. Alright, now it's time to time the engine. And by that I mean the timing of the camshaft and the valves in relation to the crankshaft and the pistons. Not to be confused with ignition timing. Now I know that's obvious to most of you, but if you're new to this, you hear words like that being thrown around, and so timing right now refers to timing the valves, not the ignition, okay? Now on these Land Rover motors, for the camshaft, this is very simple. We lined up the inside P with the key on the camshaft, so this sprocket is positioned correctly on the camshaft, and now we line up the outside P with this bolt hole. Yeah, I know, that's a little weird, but that's the way they did it. So for us petrol guys, P for petrol, we are done. For you diesel guys, the whole system is different, so you'll need to look in the manual to do that. But for us, the next job is to set the crankshaft so that number 1 piston is at top dead center. I'm going to fit the front pulley just so we have something to use as a handle. And yes, this is the old one. Don't worry, this isn't the one we're going to end up using. Now, first thing I would say is, no, you can't really just look at this and say, yep, top dead center. because the piston basically pauses for a few degrees and your eyeballs can't really pick that up. Now for me, the easiest way to do this is with a dial indicator.
If you're not familiar with these, where the numbers are on the dial doesn't mean anything. It's just convenient to set 0 as the high spot, which is what I'm doing here.
Okay, so when it gets to 0, I think that's our high spot. There. Oh, too far. Direction of rotation. There. So that is top dead center. Now, what if you're not a fancy pants like me and you don't have a dial indicator? Well, what you're going to do is roughly fit your timing cover. I know that sounds painful, but there's no better way. And now, the little timing pointer doohickey thing. And this next part is important. Your original pulley. Not the new one, but the original one that Land Rover made that came with your engine. Because you can't trust the new ones. It's enough, and we can see that our mark is at top dead center. But otherwise, you would line it up with the big point in the middle. There are variations of this, so look in the service manual. But that is top dead center.
This only applies to Series 3-ish motors. I don't know exactly when they changed, but if you have an early Series 2 engine, your timing marks are on the flywheel. So you're going to need to fit your flywheel now, which is very inconvenient if you're using an engine stand.
Now we can get this out of the way.
Obviously, be careful not to turn the motor at all.
I didn't push it on all the way, so it came off pretty easy. And so that's it. That's the crankshaft in position. We can pull all this off now. But while I have everything set up perfectly on top dead center, I want to check the new pulley. And, as expected, its timing marks are garbage. So first of all, you'll notice that we have several lines instead of one. That's because the system we're using, our pointer has different pointers on it. This is top dead center. I think this is, I don't know, like about 5 degrees before top dead center. This is probably 3 and 6. I'm not sure. These petrol engines are set to top dead center, so this is the one we're concerned with. On other engines, there's a single pointer here, and these cutouts in the pulley are your various degrees. So I'm guessing that the middle line is supposed to be 0, which it isn't. And also, as this is, there's no way you could time the engine with a strobe light. So what we need to do, I'm going to mark this as accurately as I can, and then we're going to cut a new slot into this pulley.
And I forgot to record that part, but you can imagine. I ground off the crappy scratch marks, and then cut one nice deep slot with a cut-off wheel. Could have used a hacksaw.
Now we'll take this back off. Wasn't so bad, was it? Only took 5 minutes. And now, finally, fit the chain.
And of course, be careful not to rotate the crankshaft. With the pistons in, it's pretty hard to accidentally do that, but, you know, if you accidentally bump it, you'll just have to reset top dead center.
How's our mark? What do you guys think? You're looking pretty straight on at the moment. Would you say that this lines up with this? So, I think we are just fine. Put tension on the chain. I don't think I can eyeball that any closer.
Now, if you happen to be in the unfortunate position where your P just won't line up, say you're half a chain link out, there is a way. Take the chain off, position the camshaft with the P and the hole. That puts the camshaft in time with the crankshaft, and then lock the camshaft in position somehow. Then you remove the sprocket and reposition it on a different spline, which will move the outer teeth slightly. It works like a vernier. Look in the manual for more detail. I'm just telling you here so that you don't panic if you can't line up your P. There is a way.
So this is the chain tensioner, along with this stuff. And the next question is, how does this go back together? Well, that's a good question, Pocahontas. Hang on, there's a piece missing. Here's the chain wheel, and this is all original in it. It feels fine. So we're reusing all of this, although these parts are available new as well. There is an oil feed hole in the back here, so let's pre-fill this a little bit. We should get oil coming from this small hole, which we do. Okay, so that's good. Everything is clear and working properly. I believe this goes on here. Yep, that falls off.
Anyway, the point is that you need to assemble this before you attach it to the motor. You can't get the plunger into the housing if it's already bolted on.
So now we can put the chain tensioner back in, make sure that this goes in the slot. Just get the cable tie out of the way. And this spring is just hooked over here, and the straight end gets jammed up in here. We'll put a dab of Loctite on.
I used a dab of Loctite on both of the bolts. We don't need the chain tensioner coming loose, and everything else in here is locked with a washer. I wasn't mean enough to use Loctite on the nut that you can't get a socket onto though.
And that is good.
And now that the chain's on, it's a lot easier to do up this camshaft bolt.
Okay, I think that's going to be pretty good.
There's no torque figure for this bolt, by the way, just, you know, reasonably tight. And that's all there is to it. You do want to turn the engine over a couple of times, just to make sure top dead center and P stay in alignment. Make sure you put plenty of oil all over the chain, and that's it. That's the valve timing complete.
Now we've got an oil seal to go in here. This one is a little tricky because there's no shoulder to push against, but that will sit in there. And over the top of that we have this mud shield. And this is the original one, by the way. It's in remarkable condition. So we'll just put this one back in. But originally, these were held in with solid rivets like this. I guess if you wanted to be a hero, you could put solid rivets back in, but the normal thing to do is to tap these holes and put screws in, which is what we're going to do. Now, I think in the olden days, you purchased this with a kit that included self-tapping screws. I would suggest, if you can, use proper threaded machine screws instead, because these holes go all the way through and it's a lot easier to seal a proper thread than a self-tapping screw. And for the size, I'm going to use M4. Now you can't use anything. In fact, M4 is about the largest size you can get away with because your restriction is this edge. If you put a screw in, you see there's only just room enough for this style of M4 head. So we first need to drill out these holes because they're slightly less than 4mm. Well, except for this one that I've already done. Like so. We're going to be true professionals and deburr the back. And I think these are a little tight for an M4 tap, so we'll open them up to the correct size, which is 3.3mm. I keep my tap drills separate, otherwise they become rust drills, concrete masonry drills. Drill bits don't last very long around here.
Ideally, start with a taper tap. As long as you have an ounce of coordination, you'll get a nice straight cut. It's more difficult to start with an intermediate tap, but if that's all you've got, you'll manage.
Okay, I'll see you guys in about half an hour. And that's all done. So next we install the oil seal. Now, I'm going to put some compound on the outside of it. When the service manual talks about putting compound on the outside of your oil seals, it's referring to the older style seals that had a metal case. These modern ones have a rubber outer case and therefore should seal by themselves, no problem. But I normally put a light smear in anyway, just because people get in here with screwdrivers and seal pullers and things, and a little bit of compound is cheap insurance, right? And I believe that this seal just goes in flush. We may be able to do it with our fingies. This is a very critical seal, so we want to make sure it's in as nicely as possible.
Now, I've always just pushed the seal in flat like you've seen here, but you could probably pull it down with the mud shield if you think that's easier.
And now we can fit the mud shield. This gets really cruddy in behind here, I guess because rain and grime and everything hits the front of the motor and just sort of seeps in behind this shield. So what I'm going to do is just put a tiny smear of compound around the outside just to keep the worst of that out. Land Rover did that. You can see remnants of the compound there. So we'll do the same. That will do. Very nice. And now, our screw holes are a straight shot through into the oil. So we need to seal these threads. I'm going to use this stuff, thread sealant. I wouldn't use Loctite just because, you know, these are pretty small screws. You don't need to make the next guy's life any harder than you need to. This thread sealant stays soft. It doesn't really set. And I guess if you were a heathen, you could use silicone. Preferably bright red, so everybody knows that you bought the good stuff. All right, all done. The big question right now is, are we going to use compound on the gaskets? And the answer is yes. Yes, we are.
Now, you can put paper gaskets in dry and they should seal fine. When everything was brand new, that's how the motor was put together. But if you do that, you are going to get leaks. By that I mean maybe 1 out of 10 will leak for no apparent reason, and if it's your motor, you can go and change the gasket, no big deal. But if I'm going to be selling this motor, I can't have leaks. I mean, things might leak, of course, this is an old style motor, leaks happen, but I don't want the guy who pays me whatever for a motor to have to deal with a leaking timing cover just because I wanted to be a hero and put everything together dry. So I'm using a thin smear of Hylamar either side of every paper gasket. It's also nice because it holds the paper gaskets in place while you're putting things together. You could use Permatex number 2 or 3 or Loctite, have about 100 gasket dressing compounds. There are plenty out there, but what you really want to use is bright red silicone, because your oil pump is so much more efficient when it's clogged full of silicone tear-off. That's a joke, don't use silicone.
Make sure we have a good amount of grease on the seal so that it doesn't run dry to start with. And I am putting anti-seize on all of these threads, mainly these ones up this side which go all the way through because they're exposed to the weather at the back. But since we're using it here, we may as well use it on all of them. And this is the little timing pointer thingamajig. You'll notice there's a locking tab on this bottom bolt. That's because this bolt is behind the main pulley, and I guess Land Rover were worried about what would happen if this came undone. Now, I don't really want to hammer these tabs over again. You can only use locking tabs once or twice, so there's no point breaking them off. Instead, I'm just going to put a dab of Loctite on these threads. That's it, nothing crazy. I'll tighten that up with the rest of them.
Now, if you do use compound on your gaskets, you need to give that compound time to squeeze. So I nip the bolts up and then come back in 5 minutes and tighten them again. If you try and rip them tight in one shot, you'll probably just break something. Not a good plan.
Now, initially, I was talking about rebuilding the original Rover water pump. You used to be able to buy rebuild kits for these, and I figured if I could find a new old stock rebuild kit, that would be kind of nice to rebuild a genuine Rover one. But I couldn't find a genuine old rebuild kit, so if I were to rebuild this one, I would just be putting Britpart internals in it. I didn't really see the point. I may as well just use a Britpart water pump. So what we're going to use instead is this ProFlow water pump. I've already had this out and painted it, obviously. I don't know, they cost more than a Britpart one. They're apparently made in the UK, I think, and hopefully it lasts as long as the original Rover one did. These 5 smaller screws or bolts are 1/4 inch UNC, so a coarse thread. I've no idea why they decided to use a coarse thread here, but that's what they did.
Alright, that's the front of the engine pretty much done.
I will, though, slide the front pulley on, just so it's easier to turn the engine over. This could be going on for good, except this paint is a disaster. Of course, the original paint was Garbo. I put some spray paint over the top, and that's just reacted with the paint underneath. Is that engaged already? So I'll have to take this off and spray it properly, but for now it's a good handle.
Okay, that's it. What are we doing next? Distributor drive gear. Great. That's one of the fun bits. Well, I'll see you back here for that.